Hi, so mic check 1 2 3. So welcome again, and it's been some time that I put some video on Nand2Tetris. So I was thinking, let's solve exercise one of Nand2Tetris together in this video. All right, so let's begin. So I'm going here on my browser and I search for Java. I'm on Windows, so that majority can follow along and solve this. Let me download that Java runtime. Instead of Java, it's just Java runtime. Download Windows. Okay, I think it's coming as here that something. Download Java. I'm not sure which exactly, but okay. Even before that, let's go to Nand2Tetris. Home, and that's fine. Text, video, syllabus, software. That's where we want. Yeah, so you can solve this in sort of here. I think this is where it is. Or you can solve, I think this is better. So let's skip that. Or maybe not. Okay, let's do that anyway, right? So there's this. This is legacy desktop version. Tools are implemented as Java programs that run on your local PC. In order to use this version, you must blah blah blah. Able to run Java programs. So let's just see that which minimum Java version that we need. Okay. All right. Windows users. Okay. I don't. Okay. There's not proper minimum version. I think a modern Java should be fine. So Java Online, Windows Offline. Okay. That's yeah. This is confusing, and this is 64-bit. All right. This is what we go with. That's getting downloaded. Okay, it's the GRE, that's Java runtime. Even for that, let's download the zip. Download the Nand2Tetris software suite. That's what we need as well. Hit on download. Okay, that's done. I mean the previous one. So let's install this. Clicking on yes. I'm not sure if you can see my screen, but anyway, so change destination folder. I don't need that. Just I'm gonna hit on install. So that's going there. And Nand2Tetris is done, right? Okay, I'm gonna hop onto my next window, I think. Good. So let's just see the terminal. Oh, sorry. Right, that's a nice terminal for Windows. Took some time, but anyway. CD downloads. Okay, ls. Sorry, not some of private programs, but anyway. Uh, where is that? Yeah, it's Nand2Tetris. I'm not sure if there's unzip. It's not there, so I'm manually hopping into my bad at that, but hopping into File Explorer and finding that Nand2Tetris, which is on top. I think um, so. How do I extract this? Show more options. Wait a second, that's ridiculous. Okay, all right. So let me just copy this and go to my desktop. There's password. Okay, that's dangerous. So let me paste it here and let me get rid of this WhatsApp image, whatever that is. So yeah, I'm sorry. I mean, I'm doing a lot of things here instead of doing the thing. So there's Nand2Tetris. So let me just open command prompt here. Right now, ls, nothing, PowerShell, ls, And let me see if Java is there. Okay, Java is there, right? Now there's tools, right? Now there's a bunch of things as scripts. Now sh are for Linux and .bat is for Windows. There's all that, and CPU assembler, CPU emulator, hardware simulator. Yeah, that's what we need for the first project. And let me try running the hardware simulator .bat. Okay, now this runs. This is legacy. So in this video, what I showed you is like how to run these emulators, which are like bunch of Java programs, basically. I mean, this is an overview on how to run the legacy software suite of Nand2Tetris. File, you can load ship, load script, and whatnot, which we don't need for initial exercises. We can do that thing later. Yeah, so this is just an overview on how to run the legacy software suite. And you could load programs. I mean, you can experiment with that, but for now, we'll stick to uh, the online one. Close this out, which is at guest desktop one. So we downloaded Java, and yeah, so this is that one, and this saves uh, locally in the browser the code. So I'm choosing project one. So all these projects are doable in this online IDE, and then there's project one, and then there's these many to fill it up. Uh, so I'm not gonna do on my own. I'm gonna refer some things that I've done previously. So I'm gonna spin up my laptop, the other one. It's like a teleprompter or something. I'm gonna projects CD. So I have my code on the right. In the sense, I have another computer on my right, and I'm gonna see that. So I'm not gonna do the live code. So I'll just code it out and explain what part does what. So I'm choosing project one, and so there's a bunch of things to do up here. So we'll go from not all the way to Tmux 8 4-way. So I'm choosing not, and what you have, this is a project like Nand2Tetris, so you should have access to NAND built in. That's what it is. So the paths are here. So what I'm gonna do is NAND. So let me just go to not. You just short circuit A, which is in. Okay, get familiar with this language. It's in the book. And then out is out. So what I'm doing here is I'm short circuiting both pins with single input, and then there's output. So whatever I do here, it inverts and I evaluate. So it's the opposite of that. So that's NAT. Sorry, forgive me. That's not gate. So for a given signal, which is 0 and 1 for the possibilities, it is either 1 or 0, and that's not. Let's go to AND. So AND is, so you have not, what we have is not built in. It's not built in, we just did that. So we can use that abstraction to do the and we have NAND. So NAND is AND plus NOT, right? That's what it is, NAND. So what you do is invert the output, and so pass that to NAND, pass in A and B. So this is uh, inter inverted output, right? Inverted output. Okay, I don't know what is it. Okay, there's that. Okay, I'm gonna use some JavaScript notations here, but anyway. So and then you invert that out. So in, so let me just auto complete this thing. Not, wait a second. So you pass that inverted input here. Okay, this is not working for some reason. Inverted output, and then you have the out, which is a specification of this chip A and B. Undefined pin. Okay, so I'm gonna copy this. Control C, Control V. So when A is 0 and 0, out is 0. When A is either B is 1 and you do that, output is 0. And so you can see the internal pins, that is the internal pins here. So when both are 1, so the out is 1, right? So we're done with that. So let's move on to OR. So OR is, how can I do that? So let me just quickly see what is that OR. Right. So OR is you negate the inputs, you feed that to NAND. No, sorry, and you invert the output. The way to do that is let's draw out some charts for OR, right? Uh, that's it. 0, 0. That's the all the inputs, and this is the inputs. That's 0, 1, and this is 1, 0. Okay, this is all the combination for two signals, right? And you want or, what you have is and not, right? And this is some kind of reverse engineering or whatever. So or is 0 and 1, right? And 1, and this is supposed to be 1. Yeah, that's 1. That's right. This is 0. This is 0. This is 0, and this is 0. Oh wait, the last one, last bit is 1. And then there is not. This is 0. Okay, not takes 1, so this doesn't apply for that. Nonetheless, so let's see that. So what you could do, right? So there's or, and then there's and. So this converges, that's fine. And then there's 1, but here is 0. So it's invert of that, right? This is invert of that. So invert of that. But when there is 1 and 1, uh, okay. So when you do an invert, that would be 0 and 0. Right. Even if you invert at the end, you'll get 1, right? So you invert the signal, that's 0. You invert this signal, that's 0. You AND on that, so that would give you 0 again. But still you invert on that, so you get 1. So yeah, that's how it is. I mean, it takes a bit of time to sort of reverse engineer. So this is all reverse engineered code. So I'm just gonna type it out anyway. So I'm gonna do a knot here, one more knot. So this is A and this is B. And what I would do is A B naught, A naught, that is A naught, and this is B naught. So that's done. So what I'm gonna do is add that out. So this, you saw that 16, but that's for 16 bits. We'll come to that later. Pass in A, pass in B. This is out not. Yeah, weird names, but bear with me for a sec. And you not it out. N equals out not, and out is out. That's it. Okay, so this is 1. That's weird. Wait a second. I'm not supposed to feed this in. I'm supposed to feed the intermediate outputs of the not gates of each signal. So that's Perfect. 0, 0, 0 and 0, 1 we'll evaluate. That's 1. And 1, 0 evaluate. 1, 1, 1. So that's OR in 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 general. That's all. Let's do XOR. So XOR is exclusive OR, right? So that means that uh, only if one signal is high, the output should be high. So let me just quickly see what that looks like. Right. So, okay. You could reverse engineer this. I mean, I got the glimpses like how I reverse engineered, but the way to do that is you produce knots of each one. A naught, and B naught, right? So this is just your having an access to inverted signals, and you add uh, the A and B not. Wait a sec. You have the A signal and you have the B, that is B naught. So you're exclusively sort of trying out that if both are equal, you somehow cancel the signal out. And this is maybe like I'm gonna do like YY for now, and then you or this thing in the end, but for now, so you do the same thing for the other signals. This is YY. At the end, you OR that out. A equals YY and B equals XX. I'm sorry, I made a typo here. And out is out. That's it. So when there is 0, 0, there's no signal, and there's 1, you evaluate, there's 1, that's the output of exclusive OR. And then when A is 1, you have 1, and both are 1, that's 0. So that's exclusive OR. So let's move on to marks. Okay, so the way to do that marks is, so let me look at my code. And or not. Okay, before doing that, so what is marks? Marks is like you have two input signals and then there's select. Based on select, either A flows to out or B flows to out, right? Um, so you have an access to the negation of a select because we need that cell nav. I mean that you have access to. So you add certain things. You have A and B is the select nav. The other, I mean this, okay, or you can give anything you want, or maybe for this particular chip, it's like this. I cannot give select because it might invalid the test. Oh, wait a sec. I think, give me a sec. So there's A and yeah, there's A and the B is select not and out is out. Okay, it's W1 out. And then you AND it out to A is B and B equals cell and out equals W2 out. So it's just that these AND gates, when both are 1, they allow the signal and then you OR that out. That's right. Out 2 equals, sorry, out equals W2 out. So when you order out, yeah, there you go. So when there's select not, there's output. So I'm gonna have a and do eval. So there's one output. So when the select is that, it's the output of A, and then you have select toggled. The output is B. So we can toggle B and evaluate. You can see that B signal is flowing. So I'll step back for a while. I'll have something to do and I'll come back. Thanks. Yeah, so I took a break and let's work on demarks. So demarks is the other way of marks. So you have input and you have select. So based on what select is, the input signal flows either into A or B. So let's see how to do that. Let me just see my prompter. Okay. Um, yeah, so have access to the not of select. So there's select and there's cell not. So that you have, and you and two things, one and the other and. So there's a signal, common signal, which is the input, and um, I'm passing here select not. I think that's what. Okay, I forgot to mention about how to run test suite. So we'll look into that and pass the out as in. Sorry, there's a mistake. Okay, it's either A or B. So this is so when select not is up, which is in, the B should be there. So this is B and this is A. So you have this test script, and you can click run or reset or step by step. You can load that and you go that. I mean, you can proceed next. Some Google thing. I'm gonna reject that. And you just step. Still code no syntax error. So let me just try running this. It says simulation successful. The output file is identical to the compare file. So that means the hardware written code is proper. So if it passes the test, it should be valid, hopefully. So that's demarks. So let's go on to not 16. So this is nothing. So you have not 16s, nots. You have so I'm gonna. I don't know if I have Python in here. So maybe just let me go to python.org. So there's no shell. Okay. Can't I try this out? Okay, launch interactive shell. All right, so that's gonna take some time. So not in equals out. So let me just try that out. Sorry, my computer crashed. Let me just go to this thing and for in range, I think we need 16 pins. If you don't know what I'm doing, don't worry about it. So you'll know in a moment. Instead of copying a bunch of things, I'm just trying to generate that out. That's what I need. Wait a second, it's copying now. Okay, yeah. So let's come back here. That's and. So let's get back to not 16. This is where we were. I'm gonna paste this thing out. Uh, I don't know. So I missed some things. So let me just try it again. So I'm gonna close this time. Okay. So that's what we have. Copy this. Control C. Control V. I missed the semicolons. Classic. Uh, okay, the shell. It's not doing properly. But okay. Thanks to Python online shell, kind of helped to do the messy bit. Okay, I'm so sorry. So let me just try this. This is not A, this is N. If I press Control E, does it go N? Oh, that's fancy. Wait a minute. I am so sorry again. So let me just, instead of A, that's N. I just assumed that it would be A and B or whatever that is. So this is what it is at last. So I'll explain on the bed while I'm copying. Okay. My mouse is not getting released. Well, that's good. As soon as I select, it copies for me. Control V. Yeah, so 0 all the way to 15, that's the bit, exact bit, and that's mapped to exact bit of the output. Now you can toggle in specific bits like that, and if you evaluate that, only certain bits, whatever that we have made high, is inverted, and each bit is inverted, so that's what it is. So I think it's the same for and or and that, so I'm gonna just change a few things here. So that's A and D, and in is A, I mean A is that, and this is out, that's right. And then there's B equals B of that, typo there, Control E, right, okay, on my mouse, all right, so that's copied. So I'm at A and, so I'm going to paste it out. So I'll not worry about the syntax structure. So yeah, so if I turn on these two pins and maybe like bunch of something. So this bit is AND of this bit, these bit, and corresponding AND of corresponding bits, and those are all the outputs. So that's what this is. So similarly, I'll do that for OR and mux. So I just have to change uh, here that I'm just generating the redundant bits. That's it. So nothing fancy here. So I'm just copying this. Or sorry, it's been a while, so I'm just trying out with this thing in my Windows laptop. So the audio and video is not up to the mark as what I did it previously. But this is also you turn on two bits and you evaluate, and it gives you that the OR of each individual bits. So that's what it is. And you have mux. and you have select, right? So this is a bit fancy. It's not fancy, it's just, it's mux, right? And you pass on select as select, right? Select equals select, comma. So on toggling select, everything gets flows. Everything flows, sorry. That's it. So these are all marks, each individual bits, and select is common for all that out. And if you turn on this, sorry, then there's select. Okay. So the B is flowing. Now if I turn on something here and turn off this, A is flowing. That's marked 16 bits. Yeah, so this computer is 16 bits. The computer that we are going to build in this whole series is a 16-bit computer. And then there's OR 8-way, right? Uh, there's 8 in and 8 out. The thing is, as you can see here, it's in or with in 1 or with in 2 and so on. There's an efficient way of doing this with less OR gates, but I'm just gonna do the way that I did. So you have uh, or maybe uh, uh, you can OR all the way, or you can OR each two things. So how many inputs do you have? So if I'm gonna use all OR, so that's gonna require 7. So there's 4 already, so this takes 4. Am I overthinking? Or yeah, I'm not, I think. So this is 8, right? So this is in 0 and in 1. So you OR each out, right? That's what you do. So it's in the way, it's reducing things. So that's what kind of videos that I did, but yeah, it's a reduction in essence. So you have 3. I'm just gonna fill the other things out. Okay, in 5, in 6, and in 7. So you're passing each things combined, and then there's I don't know, uh, AA, BB, CC, DD, right? You got that intermediate things. Now you are uh, each two things again. I think it's the worst. I don't know. So just gonna. I I thought I optimized it, but I did not. I think you apply AA and BB, and you apply CC and DD. So this is AAA and this is BBB. So in the end, you reduce all things. That is the topmost two things that has come out, the upper levels, and then that's out. So any pin is active, you evaluate to that, so the output will be 1. So that's what this is. And if you evaluate to that, it's 0 because all the signals are 0 or low signals. So that's OR 8-way. And then there's mux 416, way 16. So let's look at that. Interesting. Uh, the thing is, this is mux, but this is 16 bits. And you have select, that is 2 bits, right? So based on the configuration of select, the signal goes to either A or B or C or D. So I'm gonna just hop onto my teleprompter, and this is marks for way 16. Uh, Here's what I'm gonna do, copying things. So I'm gonna put 3 muxes here, right? So again, I'm just reducing this problem. That's 3 muxes. So the way it goes that is here. So one bit chooses either to flow from here to there, and the other bit chooses from here to there, in essence. So A is A and B is C. So I'm going to have an option choosing from A and C and B and D. So here is B and D. So I'm not choosing A and B, right, in the first. So I'm choosing A and C, and here's B and D. So after that, so I'm going to pass select as the first bit. You can have like combinations on accomplishing this, but I did a lot of tweaking and I came up with this. I mean, it's not hard, but at the time that I was doing, it's a little wobbly. And then there's your intermediate output. So you have select and select. Here it's again 0. You pass the first bit to either choose one among this and one among that, and you have an option which is at the end to allow whichever the intermediate output is. So A is out 1 and B is out 2, and you have select, that is select of 1. This is the array notation, and out is out, and that's it. So I'm gonna close with the semicolon. I'm gonna put some random inputs like that. So let's just say there's select 1 and I evaluate this. So you can see that's, wait, let me just do 0, 0 first. As you can clearly see, that's A signal, and this is signal C. 0, 1 is supposed to be B. Let me run the test suite. Okay, that says it differs. Okay, I'm not using this thing properly. Okay, so yeah, my code has error, but I think I made a mistake. So thing is, so I'm passing 0 and 0. Sorry, I'm debugging here. If I want 1, I think this is B, right? So based on that, wait a second. That's right. Just by toggling that. So let me try this out. I'm just brute forcing the thing out. Okay. Wait, I reset this and I just sorry, reset and run. That's it. So I have to choose either A or B, the first input, or either C or D, the first input, and then I have 1, the first bit, to choose one among them. That's mux way 16, and then there's mux 8 way 16. It's, I think it's you have one more dimension, in the sense one more bits, and you have to filter things out. So let me see this. So you have option 0 and 1. That's either A or B, and then there's 0 and D. Okay, and 0 and 1, that's E and F and G and H. So I think you can pipe this out with mux and mux, 2 muxes, and mux 16, I think, or mux 4. Okay, you have muxes here. Uh, and then they have mux 16 that comes in the end. Wow, I'm solving on my own. Delete. So let's just copy this out in the end. Control X, Control V. Thing is, so here's 1, 2, 3, 4, 5, 6, 7, 8, right? So I have to choose A, B. I'm just putting random inputs here. Uh, and there's H, E, F, G, H. E, F, G, H, right? So as I can see this thing, what I know is that the 0 and 1 decides which among this, right? So if it's 0, this group gets selected. If it's 1, this group gets selected. So I'm breaking down this thing as that. So this is the intermediate output 1, and this is the intermediate output 2. So I'm going to pass these things out. So sorry, I'm breaking bit by bit here. So out 2, right? So if select happens in the Mach 16, I think it's B, is it? Or just let's go over here to Machs and see the specification. If select 0 is A or B, all right, that's okay. So we were here, I guess. Uh, this is select of first bit, is it? This is the 0th bit. Yeah, that's the 0th bit. And the output is out. And here it's select of 1 dot dot, I think. Yeah, this is a way to represent the remaining thing in this syntax. 1 dot dot 2. So it means like take the remaining bits and pipe it in, and this is the 0, 1. And let's see. So I'm gonna put some random signals. It's not random, so I'm gonna go like that. So it's like the distinguishable signals. You can toggle whichever the bits you want. And if I evaluate, that's interesting. It's supposed to be A. That's A. Now I'll toggle the one, I mean the last one, and I reevaluate. It's supposed to be B. Why it's coming as okay, I'm gonna have to okay. Let me try. Okay, so that is clear. So let's see if 0 is 0, it doesn't affect these. 1 1, that's like same. For 1 1, it's C and D. For 0 0, it's E and F. It's 1 1, it's G and H. Okay, right. Thing is, if I invert the signal somehow, will I get what I want? 2 is 1. Okay, I think I could have inverted the inputs. Uh, I'm trying the inversion here. Select of 2. Right, so why does this say is index out of range? Okay, so that is 0 and 1, right? So that is 1 and this is 0. I'll do the same here as well. That select of 1 is, hang on a minute. Yeah, I think I'm cool now. All right. Select of 0 as select of 2. Right, so again, testing some bunch of inputs. So So if I evaluate, that's 1, that's B, right? I think I'm gonna debug little by little. Sorry, I should not have guessed these things here. Should have been like pragmatic. Okay, I don't know what happened. Right, so that's in the original form. This is 1 and 2, right? Uh, so if we debug this, so 1 and 2, okay. I think we are sorted with this, right? So this group stays in one. I think I have to play around here. So uh, if I do, I'm a little confused. So if these bits are 0, it's 1 among that. If it's all 1, it's 1 among this. So let me try this out. B, C, and yeah, I just inverted that, and I'm gonna do B here and do that, right? Okay, I did not get that. That's interesting. So let me try A, B, C, D somewhere here. Okay, so if I evaluate, I'm not getting it. Interesting. Okay, which is 2 here? This is 1 and 2. And selected 0, out 1, out 2. So, oh no, some notification. So here is that. So let me see how the other thing works. So if you have A and B, A is B, okay. Okay, 8 way. Okay, that's 4, and you have out 16. That's right. If I pass, yeah, this should be 2. This is 0 to 1, 0 to 1. I'm gonna toggle B and check on this. What a dumbass thing, but okay. Maybe should I invert signals? Let's try doing that. Or if I instead invert these things out, B and wait, I was not that before. Okay, so I'm gonna do B here, and this is C. A B C D E F G H. Right. If I evaluate this, that's okay. That's signal A. If I have okay, that's there you go. So this is B, and let's do for C, which is this and that. So that's C, and if you toggle that, that's D. Okay. So I'm gonna do inputting signals here. A, E, F, G, H. So I have to just do that and toggle the other signal. So that will pipe out the other 4 signals. So here is E, and then there is F, and then there is G, and finally H. Oh, this is interesting. Let's move on to Dmark's 4-way. It's the opposite, so I think I'm not gonna do things. Okay, before even that, let's run the test suite of this. So I'm gonna do reset and run all the way. So it says simulation successful, which means the chip is correct. So D marks four-way, so I'm gonna copy the things there. If it's error, we'll do again. So you have three demuxes. Okay. It's interesting, like it's just either 0 or 1, and then you have like 16 dimension to represent some information. You have in, and you have select 0, pass in the A, that's intermediate output. You have output 2. So what we're doing here is we're passing in and select is a first bit, and then we have intermediate outputs. So we are combining this to that. So output 1 and output 2. So one signal flows either here or there, and then we are yeah, we're just passing the other one here, the other bit. I made a typo there, but let's hang on a minute. And then there's A, there's C, there's D, and then there's B. So yeah, so I'm gonna turn on A. I can't. Okay, sorry. I'm gonna turn on in. If I do eval, it's flowing to A. If I do that, so it's that configuration is flowing the signal to B. If I turn on the other thing, the third one, it's going to C, and if I turn on that, it's going to D. So that's DMUX four-way. I'm gonna do the last bit. Yeah, it's a bunch of yeah. Okay, so you have that. Um, you have DMUX. And DMUX four ways. DMUX four ways. Wait a second. We should have run the test script here. You do the reset and you run everything and it's successful. You do the DMUX 8-way. Yeah. So DMUX 4-way. So here's in. Okay, and you pass in this first bit. I think it's the intermediate outputs. Out 1 and out 2. Right, so there goes out 1 and out 2. This is not so natural for me to deal with binaries straight up. So you pass in, select 0 is 1 and select 2 is that, so it's 1 data 2. I have given select 1 and select 0 and oh, wait a second. Yeah. The other syntax, but this syntax, I'm just trying it out. Uh, in A, this is A, this is B, this is C, this is D, this is E, I guess. Yeah, this is E, this is F, this is G and H. Right, so what is missing? That's syntax error. So let's just see there's 0, and if I pass that, it's going to 1, and that's going to be, this is going to C, this is going to D, going to E, that's going to F, that's going to G. Okay, all the configuration has tested, and H, and reset and run. Okay, tests are run. So this is the first project getting familiar with basic gates and composing everything. So we start with NOT, we compose. The thing is, what we have is NAND, and it's all composition and reductions. Okay, my phone is buzzing a lot, but anyway, yeah, it's all composition and reductions all the way, and it's you start with NAND and you build NOT and you build AND OR and all the way. So you derive all this from NAND gates. It's like a universal gate. You can also do that with NOR, but not with other gates. So that's project one. And thank you. So I'll see you in the next video. Thank you so much.